time here to go over the concept of building dimensions, and again I'm going to be operating in SketchUp just to provide some context to the way that I'm thinking. So to develop a building dimension for the sake of lateral bracing requirements, part-line lateral bracing requirements, the way that I've been able to understand this best is to consider a building and then consider, like this concept or this idea of like an extending rectangle that would be surrounding that building or that floor plan. So imagine now that we're looking down on a site. Don't really need any more context than that. And I'm going to draw in what I would consider a building footprint. So let's just think of a simple building. It could be a house or anything at this point. So let's just do a rectangle to begin with. And I'm going to do it at 40 feet by 40 feet. All right, so there we have it there. Now, here we have it. It's just a square, obviously, but obviously just would represent a simple building in terms of its form. And so the building plan dimension for this building, obviously, would be 40 feet in this direction and 40 feet in this direction. Obviously, that'd be converted for meters, however that worked out. Now, this will make sense if it's a single-story building, two-story building, three-story building, whatever it is, when those floor plans stack directly above. But things get a little bit differently when we start to change things up. Obviously, not all buildings are built as squares, and so we need to be able to accommodate that in our building codes. So let's mix it up a bit. So say, for example, you have an articulation like this. Right, so the question comes up, what are the building dimensions? Like say this is our new floor plan, the perimeter of our building. What are the building dimensions for this type of floor plan? And again, I use the same principle. We are trying to develop building dimensions based on an extending rectangle that is surrounding this. And so this one, it becomes pretty clear because we've got the axes here. So in this axis, the building dimension is still 40 feet. And in this dimension, it's 40 feet as well. So this building, although we've changed the footprint, would have the same amount of bracing that would be required if it had the same amount of bands based on the building dimension. Okay, so again, we can mix this up with a few different ideas. Back in here. And essentially it could be anything. So I say this is our new building footprint. This could be, a back extension or whatever it might be. You can hear my dog whining in the background. And so again, things would change up a little bit here. So if we're extending this idea if we're using this idea of an extending rectangle, we now have a little bit of a shift in our building dimensions. So it's going to be this idea that the extending rectangle has to encompass or surround this building. So we're going to state from our origin there up to here. So in this case, we've got just over 44 feet in that direction and 40 feet in this direction. Same thing would happen if I did something out here. The building plan dimension would change from the origin to here, just over 46 in the horizontal, down here, just over 44 in the vertical. Okay, so that's the idea of building plan dimension when we're looking at it in a two-dimensional floor plan. But this would change, or could potentially change, when we start to look at different types of structures. So we're going to delve into the 3D here so that we can understand building plan dimensions at that level. So say, for example, we decide to make this a 8-story ground floor. That's our 8-foot ground floor. So I'm going to pull that up. And there is our 8-foot walls. And then we're going to create a second floor. We're going to create a second floor. We're going to put it on top here. And let's put that at 9 floors just to account for a floor system. So say for example this is now our building. So we determined on the ground floor that we had building dimensions, what was it, 44, just over 44 feet? Just over 46 feet in that direction. Over 44 feet in that direction. If the building was stacked like this, the building dimensions would be the same on the second story. But obviously not all buildings look like that, so we're going to mix it up a little bit. So again, say for example, this bump out here was reduced on that floor. Oops, it's not working because my computer sucks. Say the bump out was there, and then we bump it back in here. So on the ground floor, we'd have that 46 by 48 or whatever it was, and on the upper floor now, we'd have building dimension in the horizontal that is 40, and the building dimension in the vertical that is also 40. All right, so as you can see, it can change, all right? Our building dimensions can change per story depending on how we're calculating them, depending on what we're designing. Alternatively, this could be pushed in to be level here. This could be a ground floor down here with a little bit of a bump out. I don't really know. But there are all sorts of different things that can happen determined by the way that we design and the type of building that we design. Right, so I just want it to be understood that there's some flexibility in the code for how we design our buildings, and it's important to understand that. The same thing could happen out here. It's possible in Part 9 that you can design this as a 2-foot overhang like this. So the same thing happens. The building dimension is changing for our horizontal and vertical axis on each story, and our calculations in the building code, this subsection in particular, can account for that. We just need to be really cognizant of what story we were actually designing, and when we're doing our calculations, we need to be sure that we're referencing the correct story with the correct building dimensions.